In this lesson, we'll go over extending unit analysis. Specifically, we'll use what we've talked about in the previous lessons with units and converting units to answer some different problem types. In this section, we also introduce units of density and concentration. There are three different types of density, which describes compactness or crowding. The first is material density, which is given by mass over volume. A practical example of this is that we know that oil and water don't mix, and that's because the oil floats on top of the water. The oil is less dense than the water. Population density is given in population over a certain area. So for instance, Las Vegas has a population density of 4,376 people per square mile. So if we picture the area around UNLV, we've got Tropicana, Maryland, Flamingo, Paradise. It's roughly a square mile. Picture 4,376 people living in that space, and that's the population density of Las Vegas. You may have heard or seen population density in the news regarding the coronavirus and the spread. When we talk about a virus that spreads based on human contact, places that are more dense than others may have to do more to stop the spread, or they may have higher infection rates due to the condensed population. For instance, this became a big deal when comparing countries and the spread of the virus and how the virus was being shared amongst people, is that countries like Denmark and Sweden were often used, but however, their population densities are very different from one another. So we have to be careful when we're comparing diseases and things that spread based on denser populations with the information that we're being given. Information density is given in units of mass over units of volume. So this has to do with more of memory and digital media. Example 1. So extending unit analysis, converting 800 centimeters squared to inches squared. Okay, so we know squared typically deals with area. When we're setting up our dimensional analysis for this, we have to take into account the units that are being used. Centimeters squared means centimeters times centimeters. So we need to make sure that we account for both of those when we're setting up our units. So we have 800 centimeters times centimeters, and our goal is to get to inches times inches. Okay, so when I see this, when I see centimeters and centimeters, I make sure that I set it up twice. I need centimeters to cancel twice, so it needs to be in the denominator twice. And then my goal is to get to inches. So I'll write inches in inches. 1 inch is equal to 2.54 centimeters. So that's how I would continue to build the dimensional analysis. 1 inch, 2.54 centimeters. 1 inch is 2.54 centimeters. So when we're solving this problem, our centimeters canceled out and we're left with inches times inches. So we have 800 times 1 times 1 inches squared over 2.54 times 2.54. So we would put this in our calculator. To get 124 inches squared. For the next problem, suppose a dose of 9,000 units per kilogram of penicillin is prescribed every 6 hours for treatment of a bacterial infection. For penicillin, 400,000 units is the same as 250 milligrams. Express the dose in milligrams per kilogram of body weight. So we're given 9,000 units per kilogram. And our goal is to end at milligrams per kilogram. Okay, so we already have kilograms in the denominator, so we don't need to convert the kilogram, but we do need to convert units to milligrams. Okay, and we're given the conversion factor that 400,000 units is 250 milligrams. Units needs to go on the bottom because we need those to cancel, and milligrams goes on the top. We have 250 milligrams per 400,000 units. We check to make sure our units cancel and we're left with milligrams per kilogram, which is what we want. So to do the math in this case, we would take 9,000 times 250 and divide it by 1 times 400,000. Okay, so we'll do that in our calculator. To get, this would be 5.625 milligrams per kilogram. Second part, how many milligrams of penicillin would a 20-kilogram child take in one day? So using your intuition, you may know to multiply 20 times 5.625 milligrams. However, we'll still set this up using dimensional analysis so you can see how the units are canceling. If we have a 20-kilogram child and we want to end up in milligrams, we're giving 5.625 milligrams per 1 kilogram of body weight. So notice here how the units would cancel out, and all we have to do is take 20 times 5.625, and this would give us 112.5 milligrams. Okay, now this is where the units are really, really important. Suppose that you're a nurse or you're in the medical field and somebody says, how much penicillin does this child need? If you say 112.5, well, using your intuition and knowing what you know about units, you might know that that's milligrams, but the dosage here is really important. We wouldn't want to get it wrong to units or grams or anything else. So this is an example of why units are really important. Extending unit analysis continued. So which has more people? County A with an area of 192 miles squared and a population density of 64 people per kilometer squared, or County B with an area of 64 kilometers squared and a population density of 192 people per mile squared. Okay. So if we know the area and the population density, we should be able to multiply the two to get the total number of people. However, our units need to talk to each other here. So what you can do is either take 192 miles squared and convert it to kilometers squared, or convert kilometers squared into miles squared. Okay, the reason that we can't just multiply these two numbers is if we take 102 miles squared times 64 people per kilometer squared, what are we ending up with here? Our units would be a mess. Okay, so what I'm going to do is I'm going to take 192 miles squared and convert it to kilometers squared. Okay, so again, this is miles times miles. It needs to cancel out twice. So I'm going to put miles in the bottom. The conversion factor, 1 mile is equal to 1.6093 kilometers. Okay, so we would have kilometers, 1.6093. I need to write bigger. Give me just a second. There we go. So we have 1 mile, 1.6093, 1.6093. Double check that your units cancel, miles cancels twice, and we'd be left with kilometers squared. So we take 192 times 1.6093 times 1.6093, and we end up with 497.251 kilometers squared. Okay, so again, this is for County A. If County A has an area of 497.251 kilometers squared and a density of 64 people per kilometer squared, we can multiply those two to find out the total population. Times 64 people per kilometer squared. Notice kilometers will cancel out, and so we take our number times 64. So this would have this county would have a population of 31,824.034. For County B, we can do the same thing. You can either convert the area of kilometers squared to miles squared, or the population density of people per mile squared to kilometers squared. I'll continue to convert the area, so we'll start with 64 kilometers squared. Let me give myself a little more room. So we need kilometers to cancel twice, so that's why I've written it twice in the denominator. Oops. Okay, and then in the numerator we'll have miles, and we'll use the same conversion factor. So in this case, the 1 is going to go with the miles because that's what our conversion factor says, and we have 1.6093 in the denominator. And so we multiply what's on top. This becomes miles squared over 1.6093 times 1.6093. So if we put that in our calculator, we get 24.712. Miles squared. Okay, and then the similar process, I'm out of room a little bit, but we'll take 24.712 and multiply it by 192 to determine how many people are in County B. So I'm just going to multiply that on my calculator, and I get 4,744.683. Again, 4,744.683 comes from multiplying the area times the population density. So in this case, County A has more people. Thank you for watching. If you have any additional questions, please feel free to reach out to me.